Hi guys, welcome back to the CS Classroom. What we're going to do today is talk about threads in Python. Now, when we start any Python program, we are actually starting a thread. So we're starting an instance of the Python interpreter, which is responsible for taking our Python code and turning it into something that can be run on our processor. And when we create that instance of the Python interpreter, we're actually creating we're creating a thread, a main thread, on which our program runs. Now, this code running in the main thread can be used to initiate other separate threads that will function independently. Now, in short, what this means is that we'll have one program, but we can have multiple threads running different tasks in parallel. So that means that we can have different things happening at the same time, concurrent or simultaneously while we're running a program in our main thread. Now, usually the way this would work is you'd execute a function to run in thread 1, another function to run in thread 2, or another function to run in thread 3. Now, whether or not this actually happens in parallel, or this happens in between lines of code that are executing in your main program, depends on whether your processor has multiple cores and supports multi-threading. So if it doesn't support multi-threading, then your main program will be running, and these threads will just run in between the lines of code in your main program. So it'll run at the same time, but at the expense of the main thread of your main program. If you actually have a multi-core or multi-threaded processor, then while your main program is running, it's not going to interrupt it, but it's going to run completely in parallel. So let's go ahead and let's see what this looks like in an actual Python program, in short. So what we're going to do right here is we are going to look at just a regular program, and then we're going to threadify it. So I just made up the word threadify, by the way. That's not a real thing. But anyway, so right here we've got a simple program. We have a function called task, and in that task, all we're doing is really just making the computer go to sleep for a second. So just stop for a second. And after that, we're just using start time and end time to figure out how long it actually takes for whatever is in here to execute. So we have def task that just takes a second to execute because we're telling the computer to go to sleep for a second. And in this program, we're going to run it twice. Okay? So when we run this, it took 2 seconds to complete. This took 1 second, then this took 1 second, and we were done. Now, this happened sequentially. And no threads were used, so 1 second, 1 second. Now, if we're running this in parallel, if we're using threads, both of these should execute in 1 second. So the amount of time it takes to be completed should be 1 second. So let's go ahead and make that happen. Now, the way we're going to do this is we're going to say from threading, import task or import thread. Now, this is a library that's included as a part of Python, but we still need to import it. And this is going to stay as it is. What we're going to do is we're going to say under start time, we're going to create the thread. We're going to say t1 equals thread. Target equals task. Task referring to this function right here that we've created. And we're going to create a second thread. And they're both going to have a target of task. So really what should be happening is both of these should be running in parallel. So this will execute in 1 second, and this will execute in 1 second, and they will happen at the same time. So in order to actually make this happen, we're going to do t1.start. t2.start. And then we're going to say t1.join and t2.join. Basically what this is going to do is this is going to allow us to join back up with the main program. So yeah, basically once these threads have finished their function, or finish their task, then they're automatically going to be ended and we'll move on. So let's go ahead and let's run that. So as you can see here, we ran the function twice, so we did the same thing as in our initial example, but it only took 1 second to complete. Now, some things to take a look at right here. So we created these threads, we created thread objects, we started them, and then we allowed them to run using the join function until their task was complete. This was merely to calculate how much time the task took, and we were executing this function we specified up here in both threads. So now that we've done that, let's look at a slightly more complex example using more than just two threads. So what we're going to do right here, we're going to stick with this, but we're going to put ID. So we're going to have a parameter so that we can actually execute a thread with some input or some parameter input. And we'll just say starting the task ID. And this is pretty trivial, like it's not really doing anything with it, it's just making use of the ID. Okay? And what we're going to do now is instead of running just 2 threads, we're going to run 10 threads. So we're going to create an array called threads. So we're actually going to run this function like 10 times in 10 different threads, so they're all going to be executing at the same time. So we're going to say threads equals an array for I in range 1 to 11. T equals thread, target equals task, referring to this function, and then the parameter is going to be the parameter is going to be I. So our ID is going to be 1, or we actually need to specify that. So we'll say args equals a tuple, and that's going to be I, comma, and this comma is actually important. We could have multiple parameters if we want, but for this function we only have one parameter. And so because we're running this in a loop, our first thread is going to have an ID, right? It's going to give task an ID of 1, and then 2, then 3, and then so forth until we get to 10. Now remember, in this for loop, we're going to do this, and we're just creating the threads. So we'll say threads.append, and then T. And each time we create a thread, we're going to do t.start. And additionally, for each of those threads, we also want to run this code to execute the join function. So basically telling all the threads to stop once the function they're executing is done. So this one may be slightly off by like a millisecond or something because we're executing one and then the next and then the next and then the next. But largely, we're going to be executing this task. We're going to be executing 10 different functions. So we're going to be executing this function, but this same function is going to be executed in 10 different threads. So it's 10 threads in parallel are going to be executing this function at the same time. And rather than taking 10 seconds, if we were running in a sequence with threads, they should all happen in around 1 second. So let's see if that works. Okay, so we started the task 1, 2, 3, 4, so that was happening in this loop right here. And then we had done, and they're finished. And it took a little bit more than 1 second because there was a delay from when we started task 1 and started task 10. That just took a tiny bit of time. Now, you've kind of seen how threads work at a basic level. So then, why would we actually use threads? So, of course, we know that threads allow us to run multiple blocks of code at the same time, so we can run tasks in parallel. Now, there are 2 main types of tasks we use. So, I/O-bound, input-output bound, and CPU-bound tasks. So, we'll often use threads that involve reading and writing to and from files, so that we can accomplish that task while we're running our main program. So for example, we might have a program that allows us to input some data and then print that out into a text file, and also do, maybe conduct some other operations. Maybe inputting the data takes a long time. Maybe we input one set of data, then another set of data. We just want to do a lot of things, keeping that program open and we want to simultaneously generate a text file or CSV data. That would be a use case for threads, because we could generate data from files, or we could use data in files while we're doing other things in our program at the same time. Another one might be calculations that take a long time. So we might want to do some very complex scientific calculations and have that running in the background in a thread, but then still be able to work on our program. And oftentimes the CPU, actually both of these, would go together with a loading bar. So you might have a program, you might start a calculation, and you might have a that calculation running in a thread, and the loading bar might tell you how far along that calculation is. So those are the two main use cases. What we're going to do in our next example is we are actually going to show how you could use threads in order to read and write from a text file. Okay, so let's look at our real world example right here. I've already imported thread, and from time import perf counter. Right here we have the function replace, and what this is going to do is this is going to take a file name in as input, and in each file it's going to replace a string we enter right here with another string that we enter right here. So for example, if we put in the string the right here and a right here, it'll replace every instance of the with the string a. Okay. So we have that. We also have a function right here called def main, and we have an array of file names that correspond to these files right here. Now what we want to do is we actually want to get to the part where we use threads. So we're going to say for file in file name. I'll call this files rather. So let's say for file in files, we're going to initiate, or we're going to create a thread object. We should actually do this. We'll say threads equals, and then we'll do threads.append. Thread. Our target, remember, is going to be the function, so replace, and then args equals file name. And right here we're going to input our strings we're going to replace. So we actually have these three text files right here. And we're going to change every instance of the to the letter A. So we're going to put the in as the first parameter, and then A as the second parameter. And right here, actually, this shouldn't be file name, this should be file. Create a thread, and we do that for each one of the files for each file in our files array. And we're going to kind of do something similar to what we did before. We're going to say for thread in threads, thread.start, and then we're similarly going to do for thread in threads, thread.join. And we want to do this afterwards, after start, because we want to kick all of them off, and then we want to specify this function that allows them to finish. So we want to kind of separate our starting of the threads from our ending of the threads. Not that this ends a thread, but this decides the manner in which the thread ends. So now what we're going to do is we're just going to say start time. Well, we can actually just take it from here. We had our start time and our end time, just to kind of measure how long this takes. Start time, and then end time. And then we'll also have this one right here to give us a neat printout of how long it took. And what we're going to do is we're going to run main right here. All right, cool. Okay, so we've specified a function that allows us to replace the text in these files. We have a function here that allows us to basically create three threads and in each thread, basically execute this function to replace the with a for each of these files. So three threads running. We have one loop to start the threads, and then one loop to basically decide how we're going to end the threads. Let's go ahead and execute it. Okay, so we got all of that done. Let's see what happened right here. Yeah, so wherever we had D, we changed it to A. So A. We can also just do that kind of backwards, right? So we can go back to our function, place the A's with these, run it again. Okay, so we're back to the. Did I type that right? Did I do the or? Oh, well, yeah, I guess it did. By and large, it worked. Except now I replaced every instance of A in here with D, so like any word that had an A in it, that just became D. Anyways, that's just a practical example of how you could use threads in an I/O input-output bound context, and just generally how you could initiate multiple threads and use them in a way that will make your program more faster and more efficient. If you found value in this tutorial, please consider liking this video and subscribing to this channel. Have a nice day.